Hello, orchid addicts of all various colors and shapes, and welcome back to my channel, The Lion's Garden. My name is Leonard, and this is going to be this day's introduction. It's a bit more poor, but I hope you like it nevertheless. So, as you can see by the title of this video, today I'm going to once again be talking about my Phalaenopsis pollinating project. And this is my big, large Phalaenopsis. As you might have known from some of the previous videos I made, this is my virused Phalaenopsis. You can see by this leaf, it has this pitting, which is very typical for the orchid fleck virus. And I'm more or less confident this orchid is in a downwards path towards demise. And as you may have recalled, I have this big, pink, wonderful Schilleriana type Phalaenopsis, as you can see by this picture. Yes, and here is the remnants of all that I have left with it. My mother, that was her first orchid, basically the first orchid in our collection, and she has taken the big hard task of actually getting rid of that Phalaenopsis, and what we did, we burnt it at the stake. So yeah, that's basically the thing you have to do with irredeemably virused phals, that you have to burn them so you wouldn't spread on the infection to the other plants of your collection. And I will talk about that a bit more later on in this video. But yeah, as you can see, this is the last little remnant that I have left of that Phalaenopsis, and this is a fading flower. Yeah, as you can see here, this is a flower that almost completely has faded away, but you can still make out the, the basic principles of it. Yeah, it's going to have to go out. So yeah, I don't have my Phalaenopsis regnia anymore, as I have identified it. So regnia, what it is, as far as I have researched it, it's a hybrid between the Schilleriana and Ludemaniana. So yeah, I hope you have been able to make it fully out from the picture what it is. It's not a fragrant Phalaenopsis, but it has huge glorious leaves with slight mottling. I have not been able to find anything quite like that in the flower shops anymore. So basically speaking, that orchid is gone for good, but because of the fact that my family loved and praised that orchid so much, I very much wanted to, continue its legacy. So it is one of the orchids which made me decide to get into the Phalaenopsis breeding shenanigans. So yeah, as you might have known from my previous videos, that orchid has a very hard time of, reproducing from creating seed with other orchids, and I will explain to you why. So yeah, here I have a sheet of paper, and I will draw to you out the scheme. So, most living beings have two sets of chromosomes. Going to represent it like this, two X's. Now this represents the pairs, of chromosomes. One parent, let's say, gives 12, chromosomes to its progeny, and the other parent gives from itself. So together, the progeny is a diploid. It means it has two sets of chromosomes, and perhaps if a single set of chromosomes is 12, you time it by 2, and then you have 24 chromosomes, for an example. Now, many of the large-sized orchids, for example some cattleyas and many Phalaenopsis, and indeed this Phalaenopsis over here, the width of its bloom is 13 centimeters, and the only way you can really achieve such large blooms is by increasing the ploidity, or the chromosome numbers of the plant. So instead of a pair of chromosomes, it has 4 sets of chromosomes, so the size of the blooms is almost 2 times larger. But what will frequently, within breeding, that provides a problem, because you might have 2 very beautiful orchids, but one of them has 4 sets of these chromosomes, but the other will have 2 sets of the chromosomes, yeah? So you will breed it together. One parent will give it its 2 chromosomes, half of its genome, and the other parent will give it just 1. Yeah, and therefore you will have a triploid. Now, a triploid plant is infertile because it has problem creating, you know, viable offspring, because it has a hard time, you know, giving its chromosomes in an even number to its progeny. So, for example, this is a banana plant, or a seedless apple, or a seedless grape. It is you are able to produce these plants, but they can't produce offspring themselves because they are infertile. So what I thought, theoretically, purely theoretically, what happened with my Regnia is that its parents were the Schilleriana. It had 4 sets of chromosomes, and Luedemaniana had 2 sets of chromosomes, so the Regni has 3 sets of chromosomes, so it is infertile. Now, that doesn't mean that the plant is completely infertile. It is a very hard scientific principle, but I'm a biologist with a tendency towards genetics, so I have a comprehension of this. Let's say they have a very low ability to create offspring, and let's say in a good case it has a 5% likeliness of being able to create its progeny. So because of that, you sometimes will have a very hard time creating seeds from these plants, viable offspring. So the second parent which I, you know, decided to cross my Regni is this yellow Phalaenopsis that I identified as Sogo Manager. And as you can see, it has a wonderful pollen pod produced over here. Now I will link you in the description of this video the first episode of this breeding project. This is the second episode, and as you can see, I have attached a pink string to this bloom, which significates that it received the pollen from the pink Phalaenopsis, yeah? And the previous time I took the pollen from the yellow one and applied it to the pink one, because the pink one was much more healthy, so it has higher chances of being able to mature the seeds in the fertilized flower. You know, and this yellow Phalaenopsis, it has a very small size, so creating seeds will be a very hard task for it. But as a last resort, because frankly I'm a person who doesn't want to give up on their ambitions so easily, I took the pollen from the pink Phalaenopsis and I fertilized the yellow one, and as you can see, it is successful. The seeds are producing. You know, the flower is going under its own transformations, it's losing its blooms. Sometimes some plants, especially summer blooming species, will keep their petals, but many times they will lose them. And as you can see, this is the pollen capsule within whom are the new seeds which are being produced. Now it has a very small percentage of its seeds being fertile, because I suspect that this is a diploid. It has 2 pairs of chromosomes, and this is a triploid. It has 3 pairs of chromosomes. So basically speaking, it has a very low chance of getting fertilized, but it obviously has, and half of its progeny can theoretically be triploids and half will be diploids. You know, the scheme is drawn over here. This parent will always give a single set of chromosomes, but this can either give a single or 2, because it's unstable. So by combining these 2 together, you will either receive a triploid or a diploid. Diploids are fertile, triploids are generally speaking infertile. but you can still have a very small percentage of them succeeding within reproducing on some plants sometimes. So I'm very excited to show you that it has succeeded, so we can look forward to it producing, you know, a mixture of, you know, a progeny from these two plants. And all of the seedlings will be very different because both of these plants are hybrids, and hybrid plants will produce very varying offspring, while species plants will produce very uniform hybrids. It's a very hard subject, but I'm just trying to give you the basics. So yeah, this project has succeeded, and you can basically look forward towards this pollen capsule maturing. Hopefully it won't fail, and hopefully I'm going to be able to keep this plant healthy enough for it to mature its, you know, seeds and not die, because there's a likeliness that it will, you know, give all of its energy to its seed pod, and you know, it itself might give up on life. So that's the danger by, you know, pollinating small seedling orchids. So yeah, that's about what I wanted to show you, an update on this project, and it's very exciting. Now, this white big Phalaenopsis, I suspect it's the Sogo Euclidean, but it is a no ID. I cannot be for sure in that statement. I can't register these orchids because I don't know their IDs, but you know, I can just assume a new ID by myself, you know, for myself, but not for public usage. So that principle aside, I used the yellow Phalaenopsis, and I pollinated the big white one. I also tried to pollinate the white one with the pink Phalaenopsis, and I also gave it a try at pollinating it with my glorious red phal. This is the Harjin Fancy. You can see it has these absolutely gorgeous blooms. So I thought, why not just, you know, if this orchid is going out, I am going to get rid of it. Why not just give it a last chance of acting as a seed parent and give all of its energy into producing new plants, you know, before I get rid of it, so it would have, you know, inheritance. So I pollinated many of these flowers, and all of them failed. The pollen from the yellow failed, the pollen from the pink one failed, the pollen from this burgundy one failed. The plant, you know, flowers just wilted and fell off after a couple of days of being fertilized. So that was, you know, fairly frustrating. But as you can see, there is another flower here which has a string attached to it, you know, a red one, which significates it is pollinated. Now let's look at the signs of the plant, whether, you know, it's pollinated or not. Sorry for the vibrations in my phone. So yeah, you can see this is a new bloom, and its stem is green, significating that the flower is alive, and the basis of it is white. You know, you can, when you look at your Phalaenopsis bloom, you will notice the coloration of its flower stem, you know, and when the flower is fading, for this an example, this flower stem will gradually turn yellow and eventually fall off as the bloom itself is wilting away. But as you can see, with this recently pollinated bloom, its flower stem has turned completely green. You know, this has a white basis and this is completely green. So this for me tells you that this is a successful pollination, and you can see the basis of this flower stem is also expanding. This is the pollen pod, which is, you know, going to mature in multiple months. So the pollen from all of these orchids failed on it, so I decided to give it a go with another plant, and this is my recent purchase, another burgundy colored Phalaenopsis. It's very glorious, very exciting. These blooms are smaller than they should be, and that's because of the stress that this orchid is ongoing, because it arrived in my collection very recently, and this orchid is called Phalaenopsis acantharoge. It's not rogue, but it's rogue. I don't know how to pronounce it correctly, so sorry for that. I could not find any information about this orchid. It doesn't seem to be registered, you know, and that's a sad side. Maybe in the future we will find more information about this, but for now its parentage is unclear. But I suspect that it has a large amount of genes from the Phalaenopsis amabilis and the Phalaenopsis ludemaniana, because many of these red-colored Phalaenopsis, they have, down the line an ancestor of the summer-blooming species, and usually it's ludemaniana or Violacea. Now, on this Phalaenopsis, I was able to find its parentage. It is registered, and it has like over 20% of ludemaniana, which gives it its color. Now that's a good thing to know. So basically speaking, the genes of these two orchids are more compatible. Maybe they both have 4 sets of chromosomes. Now this is just theoretical. Maybe this has 6 sets of chromosomes or 8 sets of chromosomes, but that's not so important for now. There are programs which are usually, you have to buy them to find out the chromosome numbers of the, registered breeds, that information can be used in the future for deciding which orchids are better to be bred with each other, so you would have a more assurance. So yeah, all that aside, this Phalaenopsis and this Phalaenopsis were successful at being pollinated. So we can look in a couple of months' time. If these seeds are actually produced, they will eventually produce, viable seeds, and we can grow them. Hopefully I'm going to have mature seed pods, and I'm going to be able to, proceed on and be successful with this experiment. There are multiple methods of breeding phals, and we can try them out in the future. Now I'm going to move these orchids to the side, because I have another set of curiosities to show you. Now these white flowers belong to a species. This I ordered from Orchid Garden. Has beautiful blooms, and this is basically the ancestor of all the white and complex hybrid Phalaenopsis that you will find in your flower shop. The round size and the big blooms originate from this species, and this in particular is Phalaenopsis amabilis variation aurea, which means it has a completely yellow lip. Now the sad side about this orchid, when I ordered it, it had completely clear leaves. It was obviously healthy before I received it from Orchid Garden, but now one of its new leaves is developing these very peculiar round spots who are sinking in, very similarly to my big large Phalaenopsis, the big white one. So yeah, I am quite sure this orchid is also virused, so down the line I'm going to have to get rid of it. It's sad, taking into account that this was meant as a replacement for this, but yeah, I'm also going to have to get rid of it, and I'm slightly suspicious that this orchid was contaminated by this orchid via exchanging water. When I water my orchids, I don't let the water exchange, but when they are drying off, they have a chance of exchanging that water, so I suppose this orchid has become infected. So yeah, what I wanted to say about this one, I am very excited by creating large flowered Phalaenopsis Violacea hybrids, and this is my Phalaenopsis Violacea, and as you can see, it's creating a new spike over here. You can see its blooms in this picture, and they have a bluish tint to this. This is the variation of the Violacea, which is called Indigo. It has a bluish purple color, and I want to create Phalaenopsis amabilis and Violacea hybrids, and I want to refine them, you know, and basically speaking, somewhere along the line, create big bluish purple blooms which are very distinct fragrance. So I will want to achieve that by hybridizing Violacea with amabilis. So yeah, I'm going to get rid of this orchid because it is virus, but before I do that, I hope for my Violacea to create some blooms and then take the pollen from them and fertilize these blooms, and it should be able to create viable seeds and produce an offspring, because both of these are official species, so they should both have similar amounts of chromosomes, so they should be much more compatible with each other. So yeah, I hope you enjoyed this video. This is just about all that I wanted to share with you. I will give you a close-up of both of these white Phalaenopsis. Yeah, you can see their size in comparison and the shape comparison. The large white one has very large percentage of, you know, genes from the Phalaenopsis amabilis, like around 90, but it has a bigger number of chromosomes, so because of that it has this larger shape. And of course, selection has been made sure to create these rounder, more pleasant type blooms through hundreds of years of actually cultivating these Phalaenopsis. So yeah, this is about it, all that I wanted to share to you. Give me the thumb if you enjoyed this video, and stay tuned for more. Bye for now.